Okay, welcome to chapter 8. So we're just going to do a quick little review on exponential functions. There is a review 8.0 in the lesson booklet that you might have wanted to do before this. So we're just going to look at what the exponential function graph looks like because, of course, we would want to be able to do some curve sketching in a little bit down the road in this chapter. Okay, so an exponential function is any function in the form f of x is equal to b to the power of x, where the base b is a positive constant. So we're looking at b being greater than 0. So we're just going to look at 2 to the power of x compared to 1/2 to the power of x, and we're going to try to do this without our graphing calculator. So 2 to the power of -2 is a quarter, 2 to the power of -1 is a half, 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 squared is 4, and then we have 8. So if I plot those very carefully, maybe make this a little bigger, we would have graph looking like this. Arrows on both ends because the domain of this is all real numbers. And then I'm going to label that as f of x. And then g of x is 1/2 to the power of x. So when you do 1/2 to the power of -1/4, you get 4. And then 2, 1, 1/2, 1/4, an 1/8. So when we're graphing on this side, we are on the negative side. Make my dots bigger. 1, 2, 3, 4, and then 2. 0 is 1, 1/2, 1/4, an 1/8. A little tricky. So we get graph looking like so. All right, so hopefully you remember that there is also a horizontal asymptote at y = 0 on these graphs. And we should be labeling graphs, especially all the characteristics. And when you have more than one graph, you should be saying who is who. So when we compare the two graphs, what do we know? We should be able to see that g of x is a reflection in the y-axis of f of x. Okay, if I thought about y is equal to 1/2 to the power of x, and I thought, I could bring that 2 up, and it would be to the power of -1, and then I would see that that's 2 to the power of -x, so the b value is negative, so we've had a reflection in the y-axis. All right, so use your prior knowledge of exponential functions to go ahead and roughly sketch the following functions. Hit pause on the video and give that a try and try to do it without your graphing calculator and see what you can come up with. Okay, so I obviously cheated. I used Desmos last night when I was getting this ready. And so you can see we've got a whole bunch of reflections happening. I tried to color coordinate my reflections. There is one graph there that's not actually exponential. This guy right here, he's neither increasing nor decreasing, so he's actually not what we would consider an exponential function. So yes, b is a positive value, but he's not going to actually be 1. And all of these graphs have the horizontal asymptote, which I didn't put on my graph, at y = 0. So we have that horizontal asymptote. And so for y is equal to b to the power of x, we should be noticing that b is positive, but he is not going to be 1. Okay? All right. So why don't you tell me what the characteristics are? Now, I kind of reordered things a little bit in the booklet because I'm going to just do all the graphing stuff first before we get into limits. So we should know that the domain of all of these is all real numbers. that the range is y greater than 0. Okay, so Malmstrom, do it properly. Sorry, guys. A little out of practice. Here we go. We have a horizontal asymptote at y is equal to 0, so we only have a horizontal. And we have no x-intercepts, but there is a y-intercept at 0, 1. Of course, until we transform stuff, and then those features can change, except for the domain. All right, so again, we're going to try not to use our graphing calculator and see if we can sketch these graphs. This is just basically a review of Math 30-1 so that we can do some curve sketching later on in the chapter. Okay, so we have the function here of y is equal 2 to the power of x plus 5. So on these exponential, you have to decide who's your base. So on this graph, my base is y is equal to 2 to the power of x. So think about that. Grab a couple of points for your x and your y for your base. So if I said x was 0, y would be 1. If I said x was 1, y would be 2. Right? And then what happened to my graph? So hopefully you remember from 30 that this is a vertical translation of 5 up. So really what I have to do is add 5 to the y value to find my new y. And that would also move my horizontal asymptote 5 units up. So make sure you put that on your graph. Y equals to 5. It asked us to label. So our y-intercept moved from 0, 1 to 0, 6. And then we have the point 1, 2 moving to 1, 7. And then we're just going to do our best to give a little sketch of the graph. All right, next one. Sketch the graph of y equals negative 2 to the power of x. So again, recognize your base graph. My base graph would be y is equal to 2 to the power of x again. Same one. And I'm just pulling the easiest two values. If x is 0, y is 1. If x is 1, y is 2. What happened to the graph if I have a negative in front? That's an a value, which means that I've had a reflection in my x-axis. Okay, so what happens is that you are going to multiply your y's by negative 1, right? So if I multiply these by negative 1, I get negative 1 and negative 2. My horizontal asymptote's actually not going to move. It's going to stay there because I have no k value. And so I have a 0, negative 1. And I have the point 1, negative 2. And I should see the graph being below that asymptote and headed downwards. All right, last one. Give it a try on your own. Pause the video, see how you do. It's got a little bit more going on. Okay, so on this one, my base graph is y is equal to 10 to the power of x. So when I think about this, I got lots more going on. So when x is 0, y is still 1. When x is 1, y is 10. And this time, I got more going on. I've got, let's see, I need a little more space here. I got an h value equal to 1. So that's a horizontal translation 1 to the right. And I have a k value equal to negative 2. So I've got a vertical translation of 2 units down. Pardon me. So that's going to change my horizontal asymptote. And in fact, I can draw that in right now. I just need to label it. Y is equal to negative 2. The k value will be your horizontal asymptote on these exponential graphs. And so I've gone 1 right and 2 down. So when I am making my new point here, I have to add 1 to my x and subtract 2 from the y. So I'm going to get the new point of 1, negative 1, and in the other one, 1 plus 1 is 2, 10 minus 2 is 8. So I've got the point 1, negative 1 somewhere right there, and the point 2, 8 would be somewhere up here. And then I'm going to draw my graph with arrows on both ends. Okay, so that should have been a quick review on exponential graphs from Math 30-1. Should have seemed very straightforward and simple. This question also asked me to state the domain and range of the function and clearly state my horizontal asymptote. I've labeled it. I don't know that I've clearly stated it. So let's do our domain and range up in this little box here. So I have a domain of all real numbers. So let's write that from negative infinity to positive infinity. I have a range that is greater than negative 2, round bracket, to infinity. And my horizontal asymptote is happening at y is equal to negative 2. I don't know why I just wrote 0. There we go. So I've clearly stated what they wanted me to state. Now, we're going to get into the limit part of this. Just because I'm not going to have enough time to do all the limit stuff, I'm going to pause the video and I will come back in a second video and we'll look at the limits with the two different types of the exponential function.